So we're going to look at congruent triangles, and we're trying to prove that triangles are congruent. So we just talked about looking and determining if triangles are similar to each other, but now we're going to work on deciding if they're congruent to each other. So first thing, you might want to write this out on the sheet if you printed it. If not, you can just do this on notebook paper. But there's two important things about congruent triangles. First of all, when we talk about congruent triangles, that means that the three sides are congruent to each other and the three angles are congruent to each other. So the triangles are identical. So keep in mind that each triangle has 6 parts. 3 of them are sides and 3 of them are angles. And so when we say a triangle is congruent, we're talking about that the 3 sides of one triangle are identical to the 3 sides of the other, and then same thing with the angles. The other thing that you want to note is that you can prove that 2 triangles are congruent if you know 3 of the 6. But there's only certain ways that that can be done. So it can't just be just because the 3 angles are congruent, or, well, we'll go into that in just a few minutes. So, but you can prove that 2 triangles are congruent if you know 3 of the 6 parts, but there are specific ways that that has to be done. Okay, in a congruent statement, order matters. We talked about this when we were doing similar triangles, so this is going to be the same thing. So here's just a little practice. Whoops, let me move this up here. Okay, so triangle ABC is congruent to triangle DEF. So you can see all the markings are on there. So if we were talking about side BC, so BC is going from the 2 swipes to the 3 swipes. So that would have to match up with EF. So you can look at it on the triangle. The other thing I like to do is just look right up here. If this is written correctly, BC is going to match up with EF. So there we go. All right, here's another one, angle A. Angle A is the single swipe right here. Angle D is the single swipe. So looking at the triangles, we can see, but again, if we look at the way the triangles are named, they should be matching up perfectly. Now, the order of the first one is not important, but the second one has to match the order of the first. So angle A and angle D are the ones that are congruent there. All right, here's without looking at a triangle. So angle T is congruent to angle N. We're going to go the opposite way now. ONM. So ONM would have to match with ATB. MO would match with, correct. And then NM would match with, very good. Nice job. All right, so there are 5 ways that we can prove that triangles are congruent. And these 5 are on your paper. We're going to go through them. If you need to pause the video to catch up, please do. This one does have a time limit, so if I need to, I might need to break it into 2 videos. All right, first up, this is an example of side, side, side. So we abbreviate that, SSS. And basically what it's saying is that if the 3 sides of one triangle are congruent to the 3 sides of another triangle, then those 2 triangles are congruent. So 3 sides in one triangle are congruent to the 3 sides in the other triangle. That is what we call side, side, side. So again, pause the video if you need to. All right, the next one looks like this. This one, if you look, it has 2 sides and an angle. So what you're going to notice is that when we start naming the reason, it needs to be consecutive. Okay, so looking at that, this is called side, angle, side, because the side, the angle, and the side are congruent to the side, the angle, and the other side. Now, the angle has to be the one that's in between the 2 sides. So if we were looking at this angle up here, top left, that's not side, angle, side. All right, so here are your words. It's the 2 sides and the included angle, which means the angle that's between those 2 sides. So this angle right here, the sides of this angle are the two sides that we're talking about. All right, next one. So again, we need to pay attention to the order. So this one is an angle with a side with an angle. So you guessed it, this one is called angle side angle. And just like the side angle side, the side has to be the side that is between the two angles. So this time, we're talking about the two angles and the included side, which means the one that is in between them. All right, here is our fourth way. Again, we do need to go in order. So it's an angle followed by the next angle followed by the side. So this one is angle, angle, side. So it's the angle followed by the next angle followed by the side immediately after that. So it's two angles and one side. Now, this one is different from angle, side, angle because the side is after the two angles, not in between. All right, this is the fifth way to prove that triangles are congruent, but it's only for right triangles. Okay, now it's also important to keep in mind that if you have a right triangle, you should be using this one. This one is HL, which stands for hypotenuse leg, and it totally makes sense. First of all, we know that these two angles are both right angles, so that gives us an angle measurement right there. We know two sides of a right triangle. We can use Pythagorean theorem to find the third side. So what happens here is that when you have a right triangle where two sides are congruent to two sides of another triangle, right triangle, we could use Pythagorean theorem to figure it out. And then it would be side, side, side. But again, this one is for right triangles only, and if you have a right triangle, you should be using HL. Just a heads up, you could always use LL also. If you knew the two legs of a right triangle, you could always use Pythagorean theorem to figure out the hypotenuse. So LL is also an acceptable way to prove that triangles are congruent. Okay, so these are your 5 ways. These are the only 5 ways, and you can see that we have a combination of S's and A's. So you should notice, if you're looking through here, that there is a combination of an A with 2 S's that is not present. I hope that makes sense to you. So, angle, side, side is not a valid way to prove that triangles are congruent. Okay, it just so happens that it doesn't work. The other one that you should notice isn't here is angle, angle, angle. And that's because angle, angle, angle shows that triangles are similar, not that they are congruent. So angle, angle, angle does not work either. So here you go. No bad words, and I'm hoping you understand the purpose of that donkey down there. Okay, here are 2 markings that you can add if they aren't already marked. So keep in mind that you're going to go with the information that you're given. We can't assume anything on a triangle, but these are 2 things that you know actually from Math 8. All right, first of all, whoops, let's move this up again. Okay, if 2 triangles share the same side, that's reflexive property, and we talked about this earlier this year also, but this side right here is the same length when it's in the white triangle as when it's in the pink triangle. So anytime 2 triangles are sharing a side, you know that side's going to be congruent to itself. Okay, the other thing is something that we talked about earlier, vertical angles. Vertical angles are always congruent. So if you had a situation like this and those angles weren't marked, you can mark them because you know that vertical angles are going to be congruent. If you're ever in a situation where something like corresponding angles or alternate interior angles, alternate exterior, all of those are valid reasons as well. All right, so here is what we're doing with this. We are looking to see whether we can decide if these two triangles are congruent or not, and if so, how do we know? So you might need to go to some paper, jot this down, and again, pause the video if you need to get the triangles drawn. So when I look at this, I see a mark, 2 marks, 3 marks. I go over here, I see a mark, 2 marks, 3 marks. So this looks like these two triangles are congruent because of side, side, side. So that would be side, side, side. All right, next one. Again, trying to decide if these two triangles are congruent. If so, how? So when I look at this, I see a side and an angle, which is not going to be enough. Everything requires 3 parts, including HL, because HL has to be a right triangle. So we have leg, 2 sides, but we also have that right triangle there. So we need 3 parts. We only have 2. However, we just mentioned that vertical angles are always congruent. So if these 2 angles right here in the middle are congruent, this would give us angle, angle, side. All right, now this would not be side, side, side. It's not HL because they're not right triangles. It's not side, angle, side because we don't have 2 sides. The only other one would be if it was angle, side, angle, but in that case, the side isn't in the middle of the 2 angles, it's after it. All right, example 3. So looking at these 2 triangles, so we have corresponding sides that are congruent there, and then we have this corresponding angle. So if I look at this, this would be angle, side, side. Angle, side, side is not congruent. All right, here we go. Again, trying to decide if they're congruent or not. Now, this is not listed as being right triangles, so we cannot assume that. So we need to look at something else. So here we know that these 2 corresponding sides are congruent. We see that these 2 angles up here are congruent. There's one other thing that we know, and that is that this side is congruent to itself. So that was that reflexive property that we talked about. So if this side is congruent to itself, then that looks to me like side, angle, side. All right, example 5, deciding again if these 2 triangles are congruent or not. So if we look at this, we have 2 right triangles. So we need to look and see if HL is a possibility. The problem is we only know one of the 3 sides, so we can rule out HL, but let's see if it's one of the others. So we know that those 2 right angles are obviously congruent. Those 2 sides are congruent. Those 2 angles are congruent. So this looks to me like 2 angles with a side, and it's the side in the middle. So 2 angles with the side in the middle is going to be angle, side, angle. All right, here's another one. So we're looking at these 2 sides are congruent to each other, but they're also congruent to those 2, and that side is congruent to that side. I don't have any angles, but side, side, side is a valid way to prove that triangles are congruent. All right, let's see. We have those 2 sides are congruent to each other. These 2 sides are congruent to each other, and these 2 angles are congruent to each other. So if we look at this, we have 2 sides and an angle. So we have 2 sides and an angle. The problem is it's not the angle that's in between the 2 sides, because that would be this one. So this spells out SSA, which is just the opposite of ASS, which is not congruent. All right, last one. So we have these 2 triangles. This side's congruent to this one. This side's congruent to this one. 2 sides is not going to be enough to prove that triangles are congruent. They're not right triangles, but hopefully you remember that vertical angles are congruent, so I know these 2 angles are congruent, which then would give me side, angle, side. All right, That does it. If you need to go back through those examples, please do. But we are just working to decide if the triangles are congruent.